idea about forces, support reactions, and equilibrium equations. Now, we'll go details about few aspects of previous lesson, but not that much, as this one is designed for the students of level 1. We'll discuss the issue in the perspective of 2D plane only, two-dimensional plane. We'll not go to moments in details. We'll start with the following three basics. Number one, external forces and moments, basically directions to consider, support reactions, clarification of few confusions, and internal forces, which is basic for level 1. First, external forces. As you can see, there's maybe four types of external forces and moments. Number one is vertical, which may be upward and downward. Horizontal, which means towards left and towards right, and inclined. It can be in four direction, and moment may be anti-clockwise or clockwise. Now, at the very beginning, we should understand we have to set a coordinate system, XY coordinate system, that is XY plane. As you can see, the provision is generally we follow positive in right direction. So this is right direction positive and left direction is negative. And for Y, upward is positive and downward is negative. So if we consider the vertical forces, if it is upward, we'll write positive. If it is downward, we'll write negative. And horizontal forces, if we see it is from left to right, we write positive. If it is right to left, we write negative. In case of inclined forces, we can check, we can divide in four quadrant: first quadrant, second quadrant, third quadrant, fourth quadrant. If it is first quadrant, say here, we can resolve the forces in x and y coordinate. The x coordinate will be plus, y coordinate will be plus. Now come to the second coordinate like this. It will have a component like x component in right side, y component downward. So it will be plus and minus. Third quadrant, this is inclined this side. It will have a x component towards left and y component towards down. So both convention of sign convention will be negative. And finally, the fourth quadrant, the x component will be towards left and y component towards up. So it will be minus and plus. Now about the external moments. In case of moment, we'll consider the provision of clockwise as positive and anti-clockwise as negative. You see the clock is moving from this direction. So this is positive and this is anti-clockwise but counterclockwise, which is negative. If you consider a 3D beam, we have x, y, and z direction. If we show in 2D plane, it will the z direction will not be there. It will be a point. Similar in the case of our beam, real beam, it will be also a. A point means it is z direction. In 2D xy plane, once we write moment about a point MA, represent moment about z direction. Z axis is seen as a point in xy plane. Support reaction and moments. Say we can see there is basically three types of support. One is roller support. The picture may be any of this. It has one reaction and the reaction is perpendicular to the plane of surface, perpendicular. If it is hinge support, or we can call pinned support, it has two reaction. It can be in two direction, but this axis must be perpendicular to each other. In case of fixed support, picture may be like this. It has three reactions. Two is same as hinge and one additional moment. It may be clockwise or anti-clockwise. It may be anti-clockwise or clockwise. Now, some reactions which are equivalent to roller support, that is, it has a single line of action. As we know, the roller supports are have reactions in vertical direction, and rocker support and frictionless surface. You remember frictionless surface. It is a simply support. All will have only one reaction towards vertical. Short cable, this also have a single direction of the reactions and short link. And collar on frictionless rod, this is the collar, and frictionless pin in the slot. This has also got one reaction. Similarly, in some support behaves like hinged support, frictionless pin and rough surface. If it is rough surface, then it will have two reactions. Now, let me clarify all those things about the directions. We know the roller support, rocker support, frictionless surface, all will have the direction of the reaction perpendicular to this line of plane. This is the line of plane and this is the perpendicular direction. The force will be, there will be single force or single reaction which will be in this direction. What about short cable and short link? Its reaction will be along the link or cable, along the link or cable, along the link or cable. So its reaction will not be vertical to the plane, it will be along the link of the. Now come about collar on frictionless rod, collar and frictionless rod, and frictionless pin in slot. In slot, frictionless pin. It will have no reaction in this direction, in the plane, in this line, but its reaction will be vertical to this plane. So this, so all these forces works like roller support, but direction is most important. You should understand the direction. About hinge or pin friction, hinge or pin or frictionless pin or rough surface, it will have two reactions. You can write it anyway. One is horizontal along the line of surface, one is perpendicular to this line of surface. Or you can also write any two direction which if the axes are at 90 degrees. Now some interesting fact, transition between hinge and roller support. Say this is a roller support. It has two forces, one is horizontal, one is vertical. We know we can find the resultant of two forces P and Q cross R. The value of R will be root over P square plus Q square and the angle will be theta. I am not going to tell how theta is found out, you know it. So if we can very well discard these two and write this reaction. So this is two reaction is converted to one reaction. So we can also similarly write Ry and Rx will be converted to R with an angle theta with X. So we can write or we can say it is also a roller support. It behaves like a roller support in this direction because roller support has got only one reaction vertical to the plane of action. Now come a roller support. The roller support may behave like hinge. How? Say it is a force, you can resolve this force in two directions. And the value will be Fy will be f sin theta and Fx will be f cos theta if it is the theta. So we can divide this reaction into two components similarly. So we can understand that hinge support and roller support are almost same if you consider only the direction. We can vary it interchangeable if it is required. Now internal forces. Like support reaction, internal joints also have a set of forces and moments. as the lesson is for the student of level 1, will not directly find internal stresses or forces throughout the member of the frame. Rather, we will be limited to find basically hinge joint forces. Fixed joint force is not the scope in the scope of our lesson. We need to separate the member from joint and draw free body diagram to find the forces at joint. Free body diagram is nothing but the few sets of line to express outline of the structure using what is known as cut. Only portion of a body are selected for modeling. This technique exposes internal forces making them external, therefore allowing analysis. Say about the joint, first fixed joint. You see, portal frame, it has fixed support. Building frame, real structure is a fixed support. Steel joint, fixed support. Now, it has three reaction like our fixed joint. It is three reaction like our fixed support. One vertical, one horizontal, one moment. So it is not the scope in this lesson, so I am not going to detail. Now come to hinge joint. Hinge spring joint may appear in three ways basically. Say we have taken two figure, this figure 1 and figure 2. Now point B, point D and point E. These three joints are a bit different. Say come to point B. If we make a free body diagram, if we separate these two from point B, we'll have two members. Now this BD member is attached with ABC at the corner or edge, but ABC is not attached at the edge, rather it is attached in somewhere at the middle point, inside, not middle, inside this member. However, so it will have a two reaction in x direction FBX and y direction FBY. We have considered F means force, B means point B, and Y and X means direction. This point of ABC will have the same reaction, only opposite in direction. That is, it will have FBY and FBX. So that if we add these two, summation will be 0. Remember, there is no external force at this point B. No external force is here. So summation of the forces in x and y direction will be 0. It will be always 0. But here we come, we have an external reaction, external force. So this P external force will have two components, Py and Px. Now what happened? Similarly, two perpendicular force will appear, but one thing, this force, vertical force will not be equal, and this horizontal force will not be equal. But what will happen? Summation of all these two forces will be equal to Py, and summation of these two forces will be equal to Px. As I have written here, I have written plus minus. As I have depicted, I did not show that it plus or minus. I have written plus minus. So that summation of all forces in x direction will be equal to Px, same as original structure, and same is the case with Fy. So that's all about hinge support with external forces. Now case 2. Case 2, point D. You see point D, both the member has attached at point D and both is at the edge. So it will have also similar reaction. But what happened in the last one? Actually, A, B, C, at B point there will be bending effect, which we did not consider as it is the lesson for level 1. So this bending effect will come, but it is not in our scope, as it is not at the edge. But here, both of the members are attached at the edge, at the corner. So they will have only horizontal vertical forces, there will not be any bending effect here. Now come in case 3, both the member are connected inside the bars or inside the members, not at the edge, like this. So it will also have two set of reactions, two set of forces, x and y, and summation will be 0 similarly, and both of them will have bending effect at E, but we are not going to express in this level. And as there is no external force, the summation will be 0. Now come the pin or hinge on what happens if three or more members are connected. So far we have shown always two members were connected. Two members. You see, two members. One, two, one, two. So all were two members were connected. Now if three members, you see, one, two, three connected, and there is no external force also in this case. So three member will have similarly three sets of three pairs of forces, but all will not be of same magnitude. But one thing is same as original. Summation of fx will be 0, summation fy will be 0. So summation of this force and this force will be 0. Summation of this force and this force and this force will be 0. Same is the case here. There is also three members. Here also same thing will happen. So summation fx will be 0 and summation fi will be 0. What happen? What happens if there is an external force? Yes, if there is an external force, then the summation fx will not be 0. Summation fx and fy will be same as external force. I'll explain you while doing the problems. Other important aspects to remember: if a tie rod, cable, cord, string, rope, thread, wire, etc. is connected at any frame or structure, it will have always tension. It cannot take compression. I'll explain it again. If a continuous string is connected across the smooth and frictionless pegs, pulleys, block, etc., tension at both sides will be equal. In case of a spherical or circular member, reactions or normal forces at contact surface will be always at the tangent perpendicular to it along the center. The weight will work from the center towards the gravity. In case of truss, it is assumed that all connections are hinged and the arm are two force members, that is axial members. Tension and compression will work. It doesn't have shear force or bending moment. So the examples are here. The tie rod cables, these are the cables, these are connected cables. All the cables will have tension. So it will be tension. No compression or other force will come. Same with the case with these structures. This is the cable, this is the cable, this is the cable, this is the cable. All will have tension. Now, number 2 point. If continuous string is connected across the smooth and frictionless peg, pulley or block, tension at both sides will be equal. You see, this T1, T1, both are equal. Here it is connected with a single pulley. Here also T2, T2. This is T2, so this is T2. Same case here also. This is TA, TA, same as it is same, but this will be TA, this will be also TA. This will be same. Here also this is TA, this is also TA. And this TB will be twice TA. However, it is not scope in this lesson. Here also comes one pulley is pulling two blocks, so this one and this one will be same. Here this one and this one tension will be same. Here this one and this one tension will be same. Here, this one and this one tension will be same. Now come about spherical or circular members. Its reaction will be from center downward. Value will be WmG, and it's not sorry, not reaction. Its force will work along this vertical direction, the gravity from the center, and the reaction will be tangent perpendicular to the tangent towards the center. It is also this is tangent, this perpendicular tangent towards center. If you come here also, same thing will happen. As I have shown it separately, this this force will work, its weight will work Wmg from the center, and its reaction will be perpendicular to the tangent towards the center. Now about the truss, this is the actual truss. It is either bolted or welded like fixed support, but our assumption is these are all are pin connected. Why? That I will explain later. So once it is pin connected, once we solve the problem, we draw it like this, and the free body diagram will be like this. You see, this is have only compression, this has tension, this is compression, this is tension, and this is tension. No shear or bending or transverse force is there. There is no transverse force. Only axial force will come here. In case of truss, which I will explain during the class of truss. Now assumptions. Few assumptions. Self-weight allowed or ignored. You see in your book there are some problem where it is written ignore self-weight or there is no self-weight, something like that. So once there is no self-weight, you do the problem same way it is shown in the figure. But if self-weight is allowed or if it's told that self-weight is there, then you will have to show the self-weight at the center towards the gravity direction. So it is W is equal to mg, here 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 W is equal to mg, and all the force is working at the center towards gravity direction, that is vertical downward. Now friction less or with friction. Say this is a block is pushed on a surface. If we consider there is no friction, only normal force will work or reaction will work, only single reaction will work, no friction. But if we consider friction, then an additional force, frictional force will come towards the direction opposite to the motion or tendency to the motion. Same case with a simple support. Say a bar is simply supported on a frictionless surface, it will have only single reaction like this. But if we consider rough surface, it will have a hinge-like support, hinge-like support, like one is vertical, one horizontal, or you can write it in one inclined directions. Now application of equilibrium equations. So we know we have equilibrium equation for transition. Transition means towards x or towards y direction. Once we use the equation, summation of fx is equal to 0. So this is same like external force, that fx all summation fx is 0, all force towards right will be plus, all force towards left will be minus. Then total summation will be 0. This is plus direction, this is minus direction. Similarly, if we take summation fy is equal to 0, upward will be positive, downward negative. Summation of all forces will be 0. Now comes with the rotation. When we would take the moment equation ma, we will consider the provision of clockwise positive. That means clockwise. You see the clock moves this direction. This is positive and this is negative. So clockwise positive and anti-clockwise negative. Remember one thing, so that you are not confusing. It is not confusing. So I'm giving an example. Say if you this is a point about which you are taking moment, this is the clockwise direction. So if the force is at the right, it is towards downward, or if the force is at the left, it is towards upward. If the force is on the top, towards right, and if the force is on the bottom, towards left, any of these will have always positive. In case of negative, you see this is B point, this is negative anti-clockwise direction, this is anti-clockwise direction. It was clockwise direction. So it is the opposite. If a force is towards right and it is upward direction, if force is towards left, it is downward direction. If force is on the top and it is towards left direction, and if force is at the bottom, it is right direction, all or any of these effect will have negative effect in the equation. So it is anti-conductivity. So let me give an example. Say there is a frame, the Q force is working here. If we take moment from A, so this Q force is at the right and towards downward. Q force is at the right and towards downward like this. So it will be Q1 into L1. The sign will be plus. If we take moment from B, this is the Q is towards left and downward. This is like this, towards left and downward. It will be minus Q into L2. This is how we'll consider the clockwise anti-clockwise or plus minus sign in the equation. Now, last but not the least, remember once we are taking moment about a point, it is Z direction because you will not require now, but in level 2, you will be needed this. So, here I want to clarify one thing. Taking moment about a point means moment about Z direction. Thank you very much. Now our next lesson will be on free body diagram and solution approach. Thank you very much.